this is your Vani ma'am back again with one more very important session, that is name reactions in one shot. So you all remember, no, students, as a child when we were in LKG, we used to study A for apple, B for ball, C for cat, D for dog. You remember that? Yes. With that, our study has started. Now I'm going to take you to that alphabetical order in that way. I will be learning all the name reactions. Point number one. Second point is I have given a very important technique to learn the name reactions. Please watch the video till the end. Next important thing, all the reactions of your NCERT are covered. This particular video will be helpful for your CBSE examination, JEE as well as NEET examination students. And most important thing is I have provided handwritten notes. It took a lot of time for me to prepare. Almost it took a lot. So please still note the video, take it. You'll be getting complete 3 marks from this chapter. Let's start off with the session, students. And I request all of you to watch till the end, share it with your friends so that knowledge it reaches more and more students who can't afford it. Thank you so much, students. So remember, let's start off with the session. Stay till the end. Right. As I have written, all name reactions in one shot, that is from A to Z, all will be there, students. And that too will be studying alphabetical order. That is what is important. So there is a technique to study this. So I'll present that in front of you all. Just check, students. Right. As we all know, A for apple. In the same way, A for aldol condensation reaction. Easy, right? So this aldol condensation reaction, if I have to see, aldol condensation reaction, whenever you are studying, important thing, try to make it into 3 different columns. Check, students. First important, name of the reaction. Second, reactant 1. If there is any reactant 2, what is the reagent or what are the temperature conditions and what is the product. So all would be in this one particular page. So when you speak about aldol, basically we very well know the compounds having alpha hydrogen only will undergo aldol condensation. So what are possible? I have given you both the possibilities. One is ethanol, one is acetone. So here 2 molecules of ethanol are combining, 2 molecules of acetone are combining. What is important, students? It's going to occur in the presence of a dilute base. So it can be sodium carbonate also, it can be barium hydroxide. 2 molecules of ethanol with 2 molecules of acetone are combining. Finally, what do we get? If 2 ethanols or 2 aldehydes combine, we are going to get aldol product. If 2 acetones or 2 ketones are combining, we are going to get a compound that's nothing but 4-hydroxy, 4-methyl, 2-pentanone. That means a sort of ketal sort of thing. Correct, no, students? Now, ketal, aldol and ketal. Now, what is the final product? So simple, I made it into one page. Now, this is your basic final product, that is nothing but formation of crotonaldehyde or butenol. Okay, this is what I studied for aldol. Next alphabet is B, students. B stands for ball. B stands for benzoin condensation, Ball-Schiemann reaction, Bovelt-Blank reduction. So you need to learn all these 3 for your board examination as well as competitive exams. So what did I do? I have divided the page again into 1, 2, 3, 4 and 5. First I have written alphabet B stands for name of the reaction. What is the reactant? In this case, 2 benzaldehyde molecules will condense. In the presence of what? The reagent would be alcoholic KCN. And you're going to heat. Both will combine together and forms a compound called benzoin. So that's why benzoin condensation. In the same way, Ball-Schiemann reaction, what are we going to take? We are going to take BTC. What are we preparing? We are preparing fluorobenzenes in the presence of what reagent? HBF4. So all the information is there in one page. Yes, students. In the same way, what did I do? I have taken the next page, Bovelt-Blank reduction. Bovelt-Blank reduction. What is a reactant? Ethyl acetate. So ethyl acetate in the presence of sodium and ethanol, it undergoes reduction process. You can also use a reducing agent like lithium aluminium hydride, where there's a cleavage of the bond where you're going to get one alcohol and one basically the same. Both the alcohols are going to be prepared from this. That is the reduction. Addition of two hydrogens on both the sides. Isn't it easy, students? Yes. Then C comes for C for cat, as we have studied. And for your good organic reactions, Canizaros reaction, Carbilamine reaction, Claisen condensation reaction, Claisen Shidmit reaction, Clemenson's reduction, coupling. So what did I do? I have divided again the whole page into name reaction, reactant 1, reactant 2, reagent, and the product. So basically what is there in Canizaros reaction? The condition is no alpha hydrogen. So what will react? Either formaldehyde will react or two molecules of benzaldehyde will react in the presence of what? Concentrated sodium hydroxide. What product is you getting? One will be oxidized product, one will be reduced product. So in both the cases, one is alcohol, one is salt of that particular metal. That also I have mentioned here in both the cases. So when Canizaros is given, the whole component is here. Easy. Next, students. After this carbilamine reaction, basically carbilamine reaction is characteristic for primary amines. In the presence of what? In the presence of chloroform and an alcoholic KOH as a base. So when primary amines combine with chloroform and you are heating it, you will be getting an offensive smelling compound. That's nothing but ethyl carbilamine. If you take aniline, phenyl carbilamine. So the whole reaction is here representing the importance of carbilamine reaction. Next comes Claisen condensation reaction, Claisen Shidmit reaction. So two molecules of ethyl acetate I have taken, the reagent I have mentioned here, and what is in Claisen condensation? We are going to get an ester that the acetoacetate in the form of an ester, that is your CH3COO, CH3CO. Basically the basic formation of ester is what is mentioned. So ethanol also is formed. When you take Claisen Shidmit, you are going to combine one benzaldehyde molecule and acetaldehyde molecule. You require dilute sodium hydroxide and you're preparing cinnamaldehyde. Cinnamaldehyde is this compound. So I have given the whole concept of the reaction. You can directly note it. Next, I have taken next reaction, Clemenson. So there are three possibilities, students. Ethanol, acetone, and acetophenone undergoes Clemenson reduction. When we say reduction, it is addition of hydrogen. For that, we are using zinc amalgam and concentrated HCl, where all the three cases hydrocarbons are prepared. All the three cases hydrocarbons are prepared. Correct? So Clemenson reaction is used to prepare hydrocarbons. I think the page is clear. Next, I have done coupling reaction. So same name reaction, reactant 1, reactant 2, reagent or reaction conditions, that be any temperature, pressure sort of things, and the product. Finally, in coupling reaction, BDC is going to combine with aniline, concept number 1. Second, BDC is going to combine with phenol. This is concept number 2. What temperature? Less than 5 degree temperature. What are you going to get? You are going to get para-aminobenzene. This is your para group. This is azobenzene, not amino, azobenzene. Basically, we are preparing azobenzenes, which is an orange colored dye. So what is this, students? It is an orange colored dye. These are all dyes which you are preparing. Orange colored dye. Correct, no? So that also I have written in one page. Next, D for duck. We have studied that. So D stands for diazotization reaction, students. So in diazotization, I have written the name of the reaction. What is important? Here you are going to use HNO2, nitrous acid. What are we preparing? Basically, we are preparing BDC. In diazotization reaction, we are preparing BDC. From where? From aniline. So this is the type of conversion also. So how I have prepared BDC? I have just shown you here. Taking NaNO2 and HCl, you will be getting a nitrous acid. That nitrous acid you are going to combine with the salt of aniline, right? And finally, you're going to prepare BDC. That's the whole reaction of diazotization. I have written here which reaction conditions less than 5 degree. Got it, students? Very good. Now, E stands for esterification reaction, and we have studied in LKG. E stands for elephant. So, two reactions are there. One is esterification, one is Itards. Both the reactions I have mentioned here. For esterification, we very well know acid reacts with and alcohol in the presence of concentrated sulfuric acid, which is reversible, and finally we get esters. In ITARD reaction, same thing students, almost a toluene we are going to take, not same, basically we are going to take chromyl chloride. So chromyl chloride in the presence of carbon tetrachloride and water, you'll be getting benzaldehyde. So nothing, when they ask you convert toluene to benzaldehyde, you can use ITARDs. Isn't it easy? Next comes F. F stands for FAN. F stands for Finkelstein reaction, Fittig reaction, Friedel-Crafts alkylation reaction, Friedel-Crafts acylation reaction. So I have taken all the reactions in one page. You very well know Finkelstein is used to prepare iodoalkenes. Where what presence? You are going to convert chloro to iodo. With what students? Potassium iodide and acetone. These two are required as solvents to prepare. So I have taken two examples, chloro and bromo, and I have got iodoalkenes. When it comes to Fittig reaction, you are going to take two aryl rings in the presence of sodium metal and dry ether, and you are going to prepare biphenyls. Simple? Yes. Then Friedel-Crafts alkylation and acylation. So in alkylation, you very well know benzene combines with methyl chloride in the presence of anhydrous AlCl3, which will act as a Lewis acid. Finally, you are going to get conversion of benzene to toluene. Correct? So Fittig reaction, Friedel-Crafts alkylation reaction, then acylation. So Friedel-Crafts acylation can be done with benzene in combination of acetyl chloride, acetic anhydride, benzoyl chloride, all the three. What do you require? You require an Lewis acid anhydrous AlCl3. In the first case and the second case, when you react with benzene with these two, you will be getting acetophenone, both the cases. And when you react with benzoyl chloride, you will be getting benzophenone. So I have written all the reactions in one page. Is it useful, students? Yes. G stands for grapes now. G stands for Gabriel-Thalamide synthesis, Gattermann's reaction, Gattermann-Koch reaction, Gattermann-aldehyde reaction. So all the reactions I have written. Thalamide also I have mentioned here. Gattermann's reaction also I have mentioned. So basically, students, thalamide, in this we are preparing, the main aim is we are preparing primary amines. This is going to undergo potassium thalamide, alkyl thalamide, like that, step by step. I have written the direct reaction. If you don't remember the whole thing, you can write this. You will be getting mark for this. 50% the mark, not all examiners, but product is mentioned. Yes, you will get mark for that. Then comes Gattermann's reaction, where you are going to take BDC, treat it with copper in the presence of HCl, chlorobenzene. If you take copper in the presence of HBr, bromobenzene. In both the cases, nitrogen gas is out. So it's an idea of the overall name reaction in one page. Next comes Gattermann-Koch and Gattermann-aldehyde. In Gattermann-Koch, we are going to convert benzene to benzaldehyde. Benzene to benzaldehyde, students, and important thing, these are the reaction conditions. RC stands for reaction condition. Reaction conditions. Okay. Then Gattermann-aldehyde synthesis, where you are converting phenol to orthohydroxybenzaldehyde in the presence of Lewis reagent. So in aldehyde, you are going to take HCl in the presence of HCl, where you prepare phenol to orthohydroxybenzaldehyde. Next comes H. H for horse, which we have studied. But in your chemistry, H stands for Hell-Volhard-Zielinski reaction, Hoffmann bromamide reaction, and Hinsberg test and Hunt-Deaker reaction. So all the things I have mentioned in halo form, we very well know. Primary alcohols will undergo, aldehydes will undergo, methyl ketones will undergo. So I have written all the reactants, that is iodine in the presence of a base. Everywhere you will be getting the formation of iodoform in yellow color PPT. So the complete haloform reaction is here. Isn't it, students? Next comes HVZ reaction. Hell-Volhard-Zielinski reaction, where you are going to convert acetic acid that is containing the alpha basically the alpha hydrogen is going to form trichloroacetic acids. What do you require? Chlorine and red phosphorus. So you're going to prepare alpha halo acids. Adjacent to the carboxylic acid, you'll be adding an halogen and preparing alpha halo acids. Then comes Hoffmann's bromamide reaction, students, where two conditions. Acetamide also undergoes Hoffmann's bromamide. Benzamide also undergoes Hoffmann's bromamide. What am I going to take? Bromine in the presence of KOH. You're heating it. What are the main products? In Hoffmann bromamide, 1 carbon less products you'll get. 1 carbon less products you'll get. So here acetamide, 1 carbon less, methylamine. Benzamide, 1 carbon less, aniline you're getting. Got it, students? Yes. So that is how you need to write the whole reaction. Check. One more. Hinsberg reagent test. This is your Hinsberg reagent. It's going to combine, primary will combine removal of HCl, you'll get N-alkyl benzene sulfonamide. You're removing HCl, 1 hydrogen, 1 Cl. Secondary amine also forms with NN dialkyl benzene sulfonamide. But when it comes to tertiary, there is no hydrogen. No hydrogen. So what does it do? This tertiary is going to form, when it combines with sodium hydroxide, forms this compound, which further reacts with your tertiary and forms a particular salt. Right, students? Understood? Right. Then comes Hunt's-Deaker reaction. Hunt's-Deaker reaction, basically you're going to take silver salts. You can take both for aliphatic and aromatic. What is important? In the presence of bromine and carbon tetrachloride. What are we preparing in Hunt's-Deaker? We are preparing alkyl halides and aryl halides, along with the release of carbon dioxide and silver bromide precipitate. Easy. Last. K stands for kite, as we have studied. We are going to see Kolb's method and Kolb-Shidmit reaction. What did I do? I have written Kolb's method. What are they going to ask you? At anode, which gas is released? Carbon dioxide gas. At cathode, which gas is released? Hydrogen gas. Okay. So we are going to take sodium acetate and we are going to do the electrolysis process where you get ions which further get liberated at the anode and liberated at the cathode. Finally, we are preparing hydrocarbon. Easy. Next, Kolb's reaction. Nothing, students. Here, Kolb-Shidmit reaction where we are going to take sodium phenoxide and carbon dioxide also. So the temperature conditions are given here. That's 120 degrees to 140 degrees, students. So 4 to 7 atmospheres. Can you tell me what are we preparing? Can anybody guess what are we preparing? Kolb-Shidmit reaction or Kolb's reaction. That is the most important reaction where, I'll give you a clue. Basically, if you forget this or if you forget this, important, I'll tell you, try to find out this product and send me in ask a doubt feature. Product and send me in ask a doubt feature. I told you how to ask. You'll be getting ask a doubt feature. Ask a doubt feature. You'll be getting 15-day subscription free for the students. Ask a doubt feature. You'll be getting 15-day free subscription. Same doubt. You just ask this. Send it to me. I'll answer you. Is it? Sure. Next, students. L stands for lion. Then N stands for Lieberman's nitroso reaction. So what did I do? I have taken the whole reaction. I have written here aliphatic and aromatic secondary amines are going to give this. I have taken the secondary amine, have reacted with nitrous acid. So what are we going to get? Nitrosoamines. That is what is important. So Lieberman's nitroso test are converting secondary amines to nitrosoamines, diethyl nitrosoamines. So I think you have seen, students, I have almost given you the complete idea of name reactions. So the alphabet which we are going to learn is M. M stands for monkey, as we have learned in LKG, and in your grade 12, M stands for your important reaction, that is Medius reaction. So here what did I do? I have taken a page where I have divided into column number 1, column number 2, 3, 4 and 5. So what are these? Name reaction. What is the name of the reaction? What is the reactant participating? what is, and if any other reactant is there in that, along with the reagent or the reaction conditions. RC stands for reaction conditions, like any temperature condition, okay, any pressure, any catalyst, any of that sort would be there. I'll be mentioning here. Along with that, the final product. That is the strategy, students. So the name reaction, which stands for M, is Medius reaction. Basically, in Medius reaction, you'll be taking nitriles, methyl, aliphatic as well as aromatic nitriles, cyanide. So reduction of nitriles is nothing but Medius reaction, students. So what will happen here, if you have C triple bond N here, you are adding 4 hydrogens. So the bond is broken. So 2 hydrogens will add here and 2 hydrogens will add here. 2 plus 2, 4. So what will you be getting? Methyl cyanide is getting converted to ethylamine, as you have seen 2 hydrogens. And phenyl cyanide is getting converted to benzylamine. What is important? The solvent, students. I'm going to use sodium in the presence of ethanol. This is the solvent. So in the exam paper, if you see the reduction in the presence of a metal catalyst and a solvent, ethanol is a solvent. That's nothing but converting cyanides to amines, converting aromatic cyanides to amines. Got it? Yes. Let us see the next reaction. The next reaction, okay, you don't have anything of N, but let us come to NOP. P stands for parrot, as we have learned in LKG. Now, P stands for Perkins reaction. Very important reaction, students. In Perkins reaction, same, I have divided the columns into 5 different, and as we have mentioned, in Perkins reaction, it's a conversion of benzaldehyde into cinnamic acid. So this particular chart will help you in learning the conversions also, right, students? So in Perkins reaction, you're going to take benzaldehyde, which has no alpha hydrogen. Along with that, you're going to take acetic anhydride. Remember this, students. So what are you going to get? There is a cleavage of the bond. Check carefully. There is a cleavage of the bond, right? And this bond, once it cleaves, one part adds to your benzaldehyde, forming, just check, this part is retained. Along with that, the leftover part, if I have to take, the remaining part comes and adds to this benzaldehyde, giving cinnamic acid, and the leftover thing is nothing but your acetic acid. So benzaldehyde is converting into cinnamic acid in the presence of sodium acetate at 455 Kelvin. So this is your Perkins reaction. Okay, next let us see. R stands for rabbit, as we have learned, and here R stands for 2 name reactions. One is Riemann-Tiemann reaction and Rosenmund reduction reaction. Right. So in Riemann-Tiemann reaction, we all know we'll be converting or we'll be taking. So basically phenol. Phenol is getting converted to salicylaldehyde, or phenol is getting converted to salicylic acid. These two are the combinations. So what is required? You require, means this particular reaction happens in the presence of chloroform or carbon tetrachloride. So both the possibilities I have given here. Chloroform or carbon tetrachloride in the presence of a base. So the reagent, base is important, temperature is important, why you're taking H plus ion. So altogether the whole reaction is given here. Right, students? So I'm not giving the reason here, but I'm giving you the reaction. That is, Riemann-Tiemann reaction is a preparation or conversion of phenol to salicylic acid, or phenol to salicylaldehyde, or phenol to salicylic acid in the presence of these two things. Right, students? Let us come and see Rosenmund reduction. So basically Rosenmund reduction in the exam. So as you all know, it's a sort of reduction process where you're going to remove oxygen in the presence of palladium and barium sulfate. You'll be also using a catalytic poison like quinoline also in this, quinoline, okay, to restrict the further action of the metal. So quinoline is also used as a catalytic poison, or you can take boiling xylene also. So what are you going to do? You're going to remove, just check, this hydrogen and this hydrogen. 1 H and Cl comes out as minus HCl, students. And what is left out? This hydrogen goes and attacks this. So addition of hydrogen is nothing but reduction, isn't it? So what are you going to get? Rosenmund reduction is a conversion of acetyl chloride or benzyl chlorides to the respective aldehydes. Once again, Rosenmund reduction is a conversion of acetyl chloride to acetaldehyde. benzoyl chloride to benzaldehyde. So only thing same, you're converting acetyl to aldehydes. In the presence of what? In the presence of palladium and barium sulfate, and to restrict its action, you're going to use, this is the catalyst, this is the catalytic poison. Okay, right. Next students, S, very important. So as a child, we have studied S stands for sun, isn't it? A bright, beautiful sun in front of us. Along with that, you have name reactions like Sabatier-Sanderson's reaction, Sandmeyer's reaction, Schotten-Baumann reaction, Shidmit reaction, Stephens reaction. Right, students? We have so many name reactions with S. Let us see all those. So in Sabatier-Sanderson's reaction, it's nothing. It's a conversion of alkynes to alkenes, alkenes to alkenes. Nothing but it is a reduction process, students. So what are you going to do every time? You're going to break the bond, add one hydrogen. So you require a metal catalyst. So nickel, I'm taking as a metal catalyst, which acts and helps in addition of hydrogen. So when you take Sandmeyer's reaction, the most famous reaction of grade 12, you're converting BDC to chlorobenzene, bromobenzene, cyanobenzene, and with the evolution of nitrogen gas. That means whenever you're heating BDC, remember, nitrogen gas evolves out. Correct? Next important thing, you're going to conduct the Sandmeyer's reaction in the presence of copper chloride, copper bromide. For getting chloride, you take CuCl and HCl. If you want bromide, you take CuBr and HBr. If you want cyanide, you take CuCN and KCN. Correct, my students? So remember, Sandmeyer's is a conversion of BDC to chloro, bromo, cyano with the evolution of nitrogen gas. That is what is important. Correct, my students? So careful. See, don't get confused between diazotization reaction and Sandmeyer's reaction, students. In the previous video, I've explained how aniline is converted to BDC, and now BDC is getting converted to alkyl halides. Got it? Next important thing, students. Schotten-Baumann reaction. Wow. So basically nothing. It's a easy reaction. Only thing you need to remember is these two. In Schotten-Baumann reaction, we are converting whether it is alcohol or phenol or aniline. Okay. Alcohols, phenols, or aniline are getting converted to the respective esters. Remember that, students. So if I take ethanol in the presence of benzoyl chloride, what am I going to do? I am going to remove this HCl, which will remove this aqueous sodium hydroxide of pyridine. So in the presence of this particular reagent, so minus HCl, and the compound joins together forming an ester. Ethyl alcohol gets converted to benzoate, phenol gets converted to phenyl benzoate, aniline gets converted to benzanilidine. Okay, so maybe this is, I'm covering that. So it's basically the compound is the, students. I'll be writing it here. I'm sorry because I have to teach. Maybe this gets covered. So this is the compound form. This is nothing but benzanilidine. This is the compound. So Schotten-Baumann reaction is used to prepare alcohols, phenols, and amines to the respective benzoates, okay, OH esters, and aniline to benza or benzanidine. Okay, right. Next thing, Shidmit reaction. It's a conversion of acid to amine. Stephens reduction is a conversion of nitriles to acetaldehydes and benzaldehydes. Remember, ma'am, what is the difference between the earlier one? There also we took nitriles. Remember, students, in the earlier one when we did, where we have taken the same nitriles, okay, same nitriles. I'll show you Medius reaction. But what is the reagent here? You've taken sodium and ethanol. In Medius reaction, you're taking sodium and ethanol and you're preparing ethylamine and benzylamine. But here, now the case is, in Stephens reduction, you are going to take same nitriles, aliphatic and aromatic. Here, 2 hydrogens you're going to add, and the metal catalyst is tin and HCl. Remember that. So when you see in the exam paper nitriles and you're seeing tin and HCl, you should prepare benzaldehyde. There, if you're seeing nitriles and sodium and ethanol, you have to prepare amines. Remember that, right? Reduction, nothing. We're breaking this bond, adding one hydrogen and hydrogen. Normally, the leftover once you break two hydrogens, finally you get the ammonia, whatever is there, no students. You take that ammonia, this nitrogen is there, no? It comes out as ammonia and HCl. You can also write it as ammonium chloride also, not a problem. Okay? Next students, U. U stands for Ullmann reaction and U stands for umbrella also. Right? So Ullmann reaction is nothing but just like your Sandmeyer's only. But here what are we doing? We are going to take iodo or arenes, okay, in the presence of copper catalyst. So what will you get, students? You will be getting same biphenyls in this case. Biphenyls in this case. That's all, no, students. So copper iodide, anyhow, the leftover copper iodide is there Cu2 This is also released out. So Ullmann reaction is a conversion of two iodo arenes into biphenyls. Right. Next, W, students. W for watch. This is what we have studied. So W name reactions are Williamson synthesis, Wolff-Kishner reduction, Woods-Fittig reaction, and Woods reaction. Let's see. So in Williamson synthesis, the most important thing. Okay. So here you need to remember you have an alkoxide and an alkyl halide. So every time there's a difference in products. What should you remember? If you have a primary alkoxide, simple. Normal NaI comes out and you get a ether. You get a symmetrical ether. Suppose if you have a secondary alkoxide. Now this is secondary alkoxide. Remember, students, if you have a secondary alkoxide, what will happen? You are, check carefully, there is a removal of NaI, okay? Removal of NaI and your ethyl comes and attacks this position. Okay, there's formation of an unsymmetrical ether. If you have aryl, bulkier alkoxides, as you see, bulkier alkoxides and a primary alkyl halides, when you're heating together, and remember students, same thing, the sodium comes out as NaBr and ethyl goes and adds to that. Okay? Yeah, that's the concept. Suppose if you have same aryl alkoxide and methyl group, right? Now remember students, same thing, NaI comes out and you'll be getting the aryl ether. Got it? So Williamson synthesis, that is what is a concept. And one more thing, if you have a tertiary group, remember tertiary alkoxide is there means, okay, you'll be asking me in the doubt session and tell me if tertiary alkoxide is there, if you're adding the methyl group, iodine comes out with which group? You're going to tell me in the ask it out feature, right? Sure. Next comes Wolff-Kishner reduction, Woods reaction and Woods-Fittig reaction, right? In Wolff-Kishner reduction, remember there are two. Clemmensen reduction and Wolff-Kishner both will prepare alkanes. So in Wolff-Kishner reduction, you have hydrazine. In the presence of potassium hydroxide strong base and a glycol as a solvent. So Wolff-Kishner reduction is used to prepare alkanes from aldehydes or from ketones. How? This oxygen is released, okay? This hydrogen, whatever is there, comes and adds to this. And the leftover nitrogen gas is out in both the cases. When I take acetaldehyde, same thing students, you have C hydrogen double bond O and H. So okay, oxygen is removed, check carefully. Oxygen is removed and the hydrogen is added here. Oxygen removed, hydrogen is added here. So you will get alkanes. When I take Woods reaction and Woods-Fittig reaction, simple. Woods reaction is a combination of two aliphatic aldehydes in the presence of sodium and dry ether to prepare alkanes, because all alkanes I have written here. Woods-Fittig reaction is nothing but an aromatic alkyl halide and aliphatic alkyl halide. Same, in the presence of sodium and dry ether, I'll be getting toluene. So all the reactions are listed out like this, students. So with this, we have completed all the name reactions starting from A to, starting from your aldol reaction to your W, that is your Woods-Fittig reaction. Woods-Fittig reaction. So my request, students, share to more and more friends. Okay, it takes a lot of time to prepare this video. Share with your friends, more and more friends, it will reach more and more.